Hey everyone, I hope you've had a great day. This is lesson 1.2, which means unit 1, geometric vectors, and lesson 2, vector laws. So I'm not going by a specific textbook per se, like section 1.2. This is just based on, again, my coworkers' awesome notes. Okay, so this video is going to go over scalar multiples and the addition and subtraction laws for vectors. I kind of went over scalar multiples in the last video, but I went over a lot of stuff. Okay, so let's go over it one more time. Let's say that we have a vector u. If I decide to put a coefficient in front, let's just call it k, it's going to be multiplying vector u. And what it'll do is it'll scale u either larger or smaller, which could result in a vector that goes in the same direction or in the opposite direction. It really depends on what k is. And so k can belong to all real numbers, and there's several different scenarios that come about from whatever k ends up being. If k is a positive number, so greater than 0, you'll notice that the k times u vector will go in the same direction as u. So let's give you an example. Here's a u vector, and I'm going to write the magnitude. Remember, when we write magnitude, we have to use absolute value symbols. This is about 4 units long. If I put a 2 in front, or a positive number in front of vector u, it becomes twice as long. So it's like putting two u's side by side. Okay, or I should say from tip of the arrow to the tail of the other arrow. So we call that tip to tail. The magnitude of this should be double the magnitude of u by itself. Okay, and notice that they're both going in the same direction, vector u and 2 vector u's. If k is a negative number or less than 0, then you'll notice that your result will be going in the opposite direction. Okay, so take a look at my example in the middle. If k was a negative 1, you can kind of see it right here, negative 1 in front of the u. We don't write the 1. U is still the same. It's the same vector, still 4 units long, but it's going in the opposite direction. So the negative would denote going in the opposite direction. Now the last scenario would be if k wasn't positive, k wasn't negative, but it was a 0. Well, if it was a 0 and you put a 0 in front of a vector, you would essentially go 0 times that vector and eliminate the entire vector completely. So I really don't know how to draw that. It's called an indeterminate. So I'm just going to write u vector with a 0 in front of it, and I don't know how to draw it, so I'm going to draw a cloud because that makes me happy. Okay, let's move on to addition and subtraction rules. If we wanted to add two vectors together, let's just say I am starting at A, I'm going to go towards B, then I'm going to be at B, and then I'm going to go towards C. Let's say I go 5 paces north and then 8 paces to the east. Well, wouldn't that be the same as if I had started here and I just decided to walk this way? It's a much shorter shortcut. So that green dotted arrow is actually what we call a resultant vector. Okay, so AC, going from A towards C, is the result of adding AB, okay, to BC. All right, and this kind of brings forth our addition law. So let me show you what that looks like. Okay, so I have two vectors right here and here. I have the triangle law of addition, and let me show you that. Okay, so in order to add these two vectors together, they have to be tip of the arrow to the tail of another arrow. Okay, so I'm going to take this one. You guys would actually have to redraw this vector exactly the same. Okay, for me, I get to Control C, Control V. Okay, so there's my V again, and I'm just going to take my U, copy it, and I'm going to put it from tip of V to tail of U. Now I can actually draw my resultant vector. So it looks like the shortcut would be starting at V, going towards the tip of U. This is U plus V, or V plus U, whatever, because U added to V is the same as V added to U. Now you would have said, well, why exactly did you start with V first? Why didn't you start with U? So let's do that. It could look like this. What if I had u first? And we drew that one first. We recreated it. Exactly the same. And then we recreated v. And tip of u to tail of v. Okay, now that they're tip to tail, again, I can draw the resultant vector starting from u going towards the tip of v. So this one would be u plus v. Don't they look the same? Like those two green vectors, again, when we draw the resultant, we kind of either use a different color or we do it dotted if we don't have different colors so that anybody looking at your work knows which one the resultant vector is. Like, don't they look the same? They look like they're going in the same direction, same slope, same magnitude. So these two vectors are exactly the same, which means that it really doesn't matter which way you decide to draw, I guess, your vector diagram. Now, I do want to show you two other rules. This will always produce a triangle. So for example, the two triangles that you see in green and black. The magnitude of the resultant, so the dotted green line, will always be less than the two magnitudes of the black lines added together. Okay, so it does look like it's shorter than the two black lines. Like if you decided to line up the black lines together, they would be shorter than the green line. Sorry, they would be longer than the green line. The green line would be shorter. This, on the other hand, the second one, does not produce a triangle. Okay, and that's where when you take both of the black lines and you decided to put them side by side, so let's just pretend that this is u, and v, if we straightened it out, was something like this. Okay, the only way that it would be equal to the resultant is if the resultant was actually not part of it at all. It was just the same length, and as you can see, this doesn't really produce a triangle at all. It's just, these are just linear lines. All right, so wanted to show you that just really quickly. Now, if we took the two triangles above and we decided to kind of smush them together, we get something called the parallelogram law of addition. I have no idea who comes up with this stuff, you guys. Okay. Don't tell anybody a math teacher told you that. Okay. If this is v, and I've put v and u tip to tail, okay, I'm also going to put, come on, be good. There we go. Vector u right there. Again, tip to tail with v. So let me write that in so that you guys don't get confused. This is u. This is v. The first triangle that we drew above was we went like this. V plus u equals to the resultant, v plus u. Okay? And then we did the other one, which is u plus v gives us the exact same thing. Same resultant. Okay, so I just wanted you guys to see that they actually do produce some sort of a parallelogram together. Let's talk about subtraction. We talked a lot about addition. Okay, so subtraction, we're going to use two vectors, v and u, and we're going to try to recreate u minus v. Now, I can write that as an addition where I go u plus, but then I need to make sure that I do an opposite of v. Okay, so how do you actually draw that? Here's my u. Okay, so there's my u right there. Plus, so very similar, I got to do tip to tail, but I have to do a negative v. Now, I don't have a negative v. This is a positive v, and it's tip to tail. This won't give you u minus v. This guy, so when I draw the resultant, will give you u plus v. So what I want to do is I do want to draw a resultant vector because it's an addition, but I want to add u with a negative v. So this is not negative v. Let's draw a negative v. Negative v would go the opposite direction, about the same length, about 6. And let me just draw my arrow. So this would be negative v, and I would put it together with u. I'm going to get rid of this because it's kind of confusing. There we go. Okay, so you got u, and we're going to add it to negative v. Okay, so remember, now that they're tip to tail, I can draw in the resultant, and that resultant right here would be u plus negative v, which is the same as saying u minus v. Okay, so that's what u minus v looks like, and if you go back to u plus v from the previous slide, it really doesn't look the same at all. We could also draw it like this, where we take negative v first. So let me take negative v, and that was over here. Okay, and let's give you an arrow, because that was this way, negative v. And let's put it tip to tail with a positive u. So I can't put it here because that would be tail to tail, right? So that's going to go right there. And there you have it. This going all the way up like that would be negative v plus u, or in other words, just u minus v. Doesn't this vector look a lot like that vector? They should be the same. They're both u minus v's. It's just we decided to draw the triangles a little bit differently, like you started a little bit differently. But the answer should still be the same. Okay, continuing. Example number 1. Let's try an example of this. Given that A's magnitude is 5, well, I already have, the vector of A, and I just decided to draw it, equals 5. It really didn't matter how long you decide to draw it, but, whatever. Vector B is 8 units long, so the magnitude is 8. The angle between them is 30, so let me write that as well, 30 degrees. Determine A plus B to 1 decimal place. Okay, so they're not in the scenario, again, where we can add them. You need to make sure they're tip to tail. Okay, so let's just draw B like right, I don't know, here. Okay, and we'll go A right there. Let's move these guys over just a bit. Okay, now they're tip to tail. Okay, let's fill out their diagrams. Got this guy. You got this guy. Okay, and then I can finally draw in A plus B. So A plus B would be this resultant vector, now that everything is tip to tail. Okay, in fact, we can even draw the 30 in there. So this 30 right here would be, if I had A here, wouldn't that 30 degrees have been right there between A and B? Okay. All right, that's going to give me a little bit of help. It's going to help me figure out some things. So I eventually want to know how long that green line is. Let's start working our way into the triangle. This guy, your theta right here, isn't that like a supplementary angle with the 30? So couldn't we just do theta equals 180 degrees minus 30 degrees, which would give me 150 degrees. Okay, so this is 150. All right. I think I have enough to actually solve for the green line now, because I'm looking at the triangle and it kind of looks like a non-right angle triangle. And so I'm going to use some of my trig. Let's extend that up a little bit. And I'm going to say, why don't we just use a cosine law? Because cosine law goes A plus B. Okay, so like that long side, right? If I decided to square that, that would be the same as the smaller sides, which are A squared plus B squared minus 2 times the magnitude of A times the magnitude of B cos theta. And you're going to be like, do we have to write the formula? And I'm going to be like, yes, you got to write the formula, because when you don't, you make mistakes. I don't know you, but you probably make mistakes. Okay, because everybody makes mistakes. All right. A plus B. Okay, and that's going to be squared. Sub in all your numbers. Magnitude of A is 5 squared. Magnitude of B is 8 squared. Minus 2, 5. I feel like I'm like directing some sort of like workout video or something. A, B, 5, 8. Let's go. 5 more. Okay, cos 150 degrees. You know how to do the cosine law. Dot, dot, dot. If you were to solve it, you would get a plus b, the resultant, the magnitude of the resultant, would equal to like about 12.6 units. Okay? The question didn't just ask you for a plus b, like it does, and that's the magnitude, but remember, if you were to describe the vector, which is technically what the question says, to describe the resultant vector, you need not only magnitude, like this is magnitude, you need the direction as well. Okay, so how exactly should we describe the direction? That's going to be a little bit more tricky. Like you got this is 12.6 units long. How would you describe the direction? Well, I mean, you can describe it as this angle relative to A if you wanted. You can say that the resultant, the green line, is 12.6 units at a certain degrees. Why don't we call that alpha? Okay, so alpha degrees relative to the A vector. Okay, so to find alpha, it looks like I could probably do like a sine law here with this guy and this guy. Okay, so I can set up a sine law where I got sine alpha over 8 equals sine 150 over 12.6, and that's approximated because the 12.6 is approximated, dot, dot, dot. I know you know how to do, sine law, cross multiply, so I'm just going to give you the answer, and you can check it. Alpha should be about 18.5 degrees. As a therefore, the way that I would write it is I would say, therefore, a plus b, which is a resultant vector, is a magnitude of 12.6 units and 18.5 degrees relative to the vector A. All right. 2 more examples. Come on, guys. You guys can do this. You got this. You got this. Properties. Properties of vectors means that if you decide to do something like a commutative property, it's very similar to polynomials. If you add a to b, b plus a is the same thing. Okay, associative means that if you put brackets in terms of priority, again, your result is going to be the same if you add them in a certain way. The identity element means that if you decide to take a vector and you add a 0 vector, okay, be very careful, the 0 still has a vector symbol because you can't take a vector and just add a number to it. It has to be adding another vector to it. Then you get the exact same identity, the same vector. Okay. The inverse means that if you add a vector to its inverse, the opposite, obviously you're going to get a 0 vector. So we can play around with any of those properties and do algebra very similarly to how we dealt with polynomials. Okay, so why don't I do this with different colors. Here is A. We're just going to say the vector A is equal to something relative to x and y's. Here's a B vector, and what you want is you want to calculate what this equals to. Okay, so 2A vectors minus 3B vectors equals to, well, 2A vectors, which is written in terms of an x and y vector, minus 3 and then B vectors, which is, again, also written relative to x and y vectors. Okay, so how exactly do we simplify this? All we're going to do is simple algebra. Okay, so 4x minus 2y, distributive law again, minus 3x, minus 12y, and simplify and put things together. That is 1x vector, subtract 14y vectors. All right. Oh yeah, you guys like this one. You guys like this stuff. This stuff is easy. If I wanted to simplify, say, several letter vectors together, remember these are how we can also write vectors. We can simplify all 3 into one vector. Okay, and I'll show you diagrammatically in a little bit, but first I'm going to show you through color. Okay. I don't like that negative SQ, so I'm going to do something to it, but I don't really want to touch the PT. Okay, so since we know that a negative SQ is the same as the positive of the opposite direction, it would be QS written with the positive. Okay, plus, and I don't really want to touch the TQ either. Okay, since they're starting to look like they might be able to be placed because we're adding tip to tail, what I'll do is I'll take PT and its tip is a T. I want to put it beside another another tail that has a T as well, because then I can combine those guys together in a resultant vector that goes from P all the way to Q. Does that make sense? Okay, because we're going to go from P to T, T to Q. Isn't that the same as just going from P to Q? Okay. I still have the red one though. So the red one is Q to S. Oh, couldn't I also combine these ones as a T all the way to S? Because if I'm going to go from T to Q, Q to S, then it would be the same as if I went from T to S. Okay, I'm getting messy now. All right, let's move this. Nope. Gonna get this out of the way. Get this. I can't move all these. All right. Okay, let's put that back. All right, so let's rewrite this. Plus T, nope. Oh, guys, why don't we just do it this way? If I have T and T, they're already tip to tail. Q and Q, that's tip to tail. Why don't we just go from P all the way to S then? So P to S. There we go, we're done. Let's show you that again. P to T, T to Q, Q to S. Isn't that the same as P to S? See, that's the thing about this course. I think a lot of times you say things, you kind of have to work through it. Sometimes you see things, sometimes you don't, and it takes a lot of practice. But by watching these videos, you guys are going to have a lot more practice under your belt. Okay, so thanks for joining me for this video. See you later.